so today we're going to be looking at sound wave. So there are a few things that you need to know here. First thing is that you need to know some of the keywords that you've learned in the beginning of the chapter. Compression, rarefaction, so where they are when it comes to sound wave, this longitudinal wave. And then in terms of loudness and pitch, so what actually affect loudness and what affect pitch, okay? So that's the first part of it. And also for your information, okay, the range of frequency that a human ear can hear from 20 hertz up until 20,000 hertz. So this is a sound wave in this picture here. And if you make a vibration from a tuning fork, so you produce a sound wave, which is a longitudinal wave. And the distance from the center of a rarefaction to the center of another rarefaction is the wavelength. And also the center of one compression to the center of another compression is also one wavelength. So this distance here, this is the wavelength. And the area where particles are closer together, we call it the compression. And the area where particles are further apart, we call it the rarefaction. We're going to be looking at other things that affect loudness and pitch too. So for loudness, it depends on the amplitude. So I'm sure you remember what amplitudes are, especially particularly how they look like on the graph itself. So it's the displacement from equilibrium, right? And how it affects loudness. As this amplitude increase, loudness will increase too. And then for pitch, it depends on frequency. So as frequency increases, then pitch will also increase. So both of the things that affect loudness and pitch are directly proportional to each other. So now we're going to have a look at these four pictures here. So the first two is sound tone P and sound tone Q. So you have to determine which tone is louder. So if you looked at the displacement here, the displacement from equilibrium, so this is the displacement from equilibrium here, then you can see that sound tone Q have a higher displacement and therefore higher amplitude. So higher amplitude mean louder. So the answer is Q, and they also ask you why. So the reason is because Q has higher amplitude. And then the second one is sound tone R and sound tone S. So we need to find which one has higher pitch. So in terms of pitch, we need to be looking at the frequency. So this one here is the wavelength. Okay, so the wavelength is from here to here. And the wavelength for this part is from here to here. So this is shorter wavelength. This is longer wavelength. So shorter wavelength means higher frequency. And longer wavelength means lower frequency. So low F, high F. So higher frequency would be higher pitch. So your answer here will be sound tone S, because S has higher frequency. Or if in your answer you said it's S because it has a shorter wavelength, that is correct too. Okay, so next part that we're going to be looking at now is the speed of sound, okay, and also the application of this speed of sound. So a typical value accepted for SPM, even though actual value may differ, for air is 330 meter per second. For water, the value accepted is around 1,400 to 1,500. It depends on the type of water actually, but yeah. So concrete around 5,000, steel roughly 3,200. So if you looked at it, then you can see that in gas, sound travels slower, and in liquid, it travels at a medium speed. And in solid, then it travels faster. So that's just how sound is. It's quite different if you compare to light and their optical density or refractive index, right? Okay. So now let's look at other things that affect the speed of sound. So the things that affect the speed of sound over here is temperature and also the materials of the medium. The pressure of air or humidity, it has a very less effect. It could affect, but it's very insignificant. So how the speed of sound will be affected by temperature. As temperature increase, then the speed will increase. And the reason is simple, because hot air has more means the particles will vibrate faster and they have higher energy. So therefore, yeah, they will move faster too. Okay. So pressure of air have no or very little effect. So in terms of materials of the medium, so you need to be able to look that is into the molecular level. So in terms of how these particles interact with each other. So in terms of the materials of medium, the closer they are packed together, then the faster the speed of sound will be, because it's easier for you to transfer the energy between atoms to another atoms. All right. So now we'll be looking at the application of the speed of sound. So what we've got here is a few pictures. The first one here is the ultrasound. So ultrasound imaging is what you use to have a look at the to create an image of how the baby is, or how the organs, your internal organs look like. So what happens is that there are electrical impulse, and also the how the image will be projected is based on the ultrasound that is reflected back. So the time will be calculated, and therefore, like if the time is fast, you reach you faster, then that means that that point is where the feet of the baby, for example. So yeah, and also it will take into account the density of the materials inside as well to produce like a better picture. And ultrasound is also used for, and we call this echolocation. So some animals like bat and dolphins, they use this in order to find their prey and go hunt for food, right? And submarine use this so that they will be able to notice if there are area where they cannot pass through. Like in this picture here, it's an island, so yeah, you need to turn around, okay? And another application is sonar. So this panel here, this green panel, is how it will look like. So all of these impulses of ultrasound will be sent in and it will be reflected back. So the time taken will be able to determine the distance between where your ship is to the location of the object that you found through the sonar machines, right? And also some cars use sonar technology as well for to detect area at the back of the car when you do a reverse parking stuff. Okay, so the definition of echo. Okay, so if you look at the picture here, this is the picture of how sonar is used to determine the depth of the ocean. Okay, so D here will be the depth, and the speed will be the speed of the sound that you use, the ultrasound that you use. So that will be the speed. And then they will calculate the time taken for that ultrasound to go down here and to come back up. Okay, so then the depth now you will consider 2 times, because going down and going up, right? So your distance become 2 times the distance. So you know that from the formula of speed is distance divided by time. But in this case, because the time is the full time between going down to the depth of the ocean and coming back to the ship, so it will be 2D. So now we're going to be looking at some practice question that involves amplitude and pitch and loudness and frequency. Okay, so there are 6 waves here, and they want to know about the frequency of it, the differences in frequency, the differences in amplitude, pitch, and loudness, and so on. So what you need to do first is to find out which one of them have the same wavelength and which one of them have the same amplitude. So we can use a ruler here. Let's determine all that. Okay, so we've determined all of that. So let's look at the question now. So question 1, which sounds have higher frequency than A? So this will be determined by looking at the wavelength. So the wavelength of A is 2.8 cm. So now you want to find something that have higher frequency, then you should find the one that have shorter wavelength than 2.8. So then shorter than 2.8 will be B and C. So that's the answer for this one. And for question 2, which sound have a lower frequency than A? So you need to find the one that have longer frequency than 2.8. So in this case here is only D, which is have a 5.6 frequency. So D. So the one that have the same pitch, so that means the same wavelength. So that will be 2.8 is A, E, and F. But we also have 2 other that have the same frequency as well, which is B and C. And then question 4, which sounds are louder than A? So here we're going to be looking at amplitude. So A is 0.9, so you want to find something louder, then it should be more than 0.9. So in this case, you got 1.2 here and 1.6. So the answer will be B and F. And then question 5, which sound has higher pitch than A but is the same volume? So higher pitch than A will be higher frequency, which is B and C. B and C. And higher volume is B because it has a 1.2 amplitude. So your answer for 5 should be B. Okay. And then question 6 asks you to compare between sound wave D and sound wave A. So sound wave D and A have the same amplitude. So you can say here, question 6, they have the same volume, but they have the different wavelength. So because A have higher frequency, so but A is a higher pitch. And then for question 7, F and A, okay, so they both have the same frequency, so same pitch, but F is louder. Okay. So you can pause the video, try out this question, and come back later for the answer. Okay, so let's have a look at this question together. First off, they ask you the phenomenon of sound wave that is applied in this picture. So it's definitely reflection of sound. And then second question is calculation. So they gave you the value of frequency and they give you the value of speed as well, and they want the wavelength. So the formula that you use for this is B equals to F lambda, and you're trying to find lambda. So your V is 1,500, 10 to the power of 5. So if you work that out, you should get 2.5 times 10 to the power of negative 3 meter. And then second question here, they give you T, the time, and they want D, the depth of the sea. So we'll be using the formula V equals to 2D over T, and we're trying to find D. Speed just now is 1,500, time 2 seconds, and divide by 2. So you will get 1,500 meter. So let's look at the summary. So you've learned about loudness and pitch and what affects them. And you also learned applications of sound, sound waves, which include ultrasound, sonar, etc. And you also learn calculation involving sonar, which is V equals to 2D over T. Right? So that's all for today. Thank you for watching.